Welcome to Tech Talk. Today we'll be talking about lambdas and how we can simplify code with lambdas and do a little bit of abstraction. So let's just dive straight in. What we have here is a basic application that we've written in C#. This is just a standard console application. I find a lot of times on tutorials where developers will try to do 17 different things at the same time. So I try to keep everything as simple as possible. So we're not doing web, we're not doing application, we're not doing anything else like that. We're just doing straight console. Now, in this console, what we're going to do is very simple. And most of my demos you'll find will have something to do with heroes because, well, I'm a superhero nut. But we're going to get a list of heroes from the database. We're going to list their powers, and we're going to list their frequent locations. Simple. For some of you, as we go through this example application, you'll immediately see different patterns and different ways that things can be applied. Just bear with me, and we'll get to kind of the finished product. Admittedly, right now, this is not a good way to structure your application. So as you can see, we have, for every data pull, we have a different method that does its own SQL configuration every single time. And as you can see, this is bad because we have absolutely no error management at all. We're not catching anything, we're not trying anything. So if this explodes, it's just going to unhandled exception and die. So let's see what the application does first. It's always a good idea when you're dealing with a legacy application to kind of run through it and make sure you understand what the output should be. So let's fire it up. Okay, so here we have our different superheroes, which the list is pretty obvious, right? Steve Rogers, Tony Stark, Bruce Wayne, Matthew Murdock, Peter Quill, and Barry Allen. So this is, again, very simple stuff. Now, let's look at the code. So whenever I'm dealing with a legacy application, the first thing I like to look at is the code, just in kind of a general pattern view. And so first we can see that this is a repeated pattern multiple times over. So let's really explore what this is doing. So first, we're getting a SQL connection, then a SQL command. We're setting the command text, and we're setting a reader. So what I'm going to do, the first thing I'm going to do is I'm going to pull this chunk of code right here into its own method. We'll worry about the parameters here in a second. For those of you wondering, this editor is called Writer, and it's by the JetBrains people. It is an excellent development environment. Not a full replacement for Visual Studio. There's a lot of functions and features. Visual Studio is super deep, and I still use Visual Studio fairly religiously, but Writer is kind of my new favorite because it gives me a lot of interesting ways to edit the code. For example, this presentation mode, which is kind of a distraction-free environment. I really enjoy this. This allows me to kind of focus on the code a little bit. If the JetBrains people are watching and they want to, thank me for that, I'm all for it. But as of right now, as of the cutting of this video, no endorsements have been made. So, getting back to it. We're going to take a look here at what we're doing and see if we can pull out some common elements. First place I like to attack is strings. So, and I'm just going to set some temporaries up here right now. So var db name, and we can replace this here. And obviously the next big one here is query. And for the time being, let's get rid of this information here. Okay. So right now, if we were to take DB name and query and simply put it into this reader here, we'd have a nicely abstracted version of this SQL call. But if you notice, we're doing something a little bit different each time with our data. So now, this is where Lambdas come in, and we can make some pretty fun stuff here. So we're going to use the action delegate provided by the .NET framework, and we are going to expect a SQL reader, and we're just going to call our action action. Now if we come down here and say action reader, oh, actually we don't want to do that inside the while. We want to let our user figure out what he's going to do with it. So now that's pretty good. But one of the things that I would always suggest, if you're dealing with multiple databases, maybe you want the DB name. I would suggest defaulting it later. What I'm going to do for right now is I'm going to make, and I know there's a lot of people out there cringing right now, but I'm going to create a const for my database name. Now, I do not recommend doing this in most applications. If you're doing MVC, if you're doing universal Windows, whatever you're doing, you want to make stuff like this configurable. You'll want to make this easy to change later on. At very least, you'll want to make this defined in your app config or your web config. But for this tutorial, that's just kind of the way we're going to go for now. So just keep in mind, this is bad. This in real life. Okay. Now that we've got that, let's go ahead and change that here. DB name, get rid of this, and we can get rid of this. Oh, and I meant to say data reader, because that's the actual class name. So now we've got a pretty cool little Lambda here, which is kind of nice. Now, one of the things that I like to do, and one of the things I typically do when I'm writing database wrappers, is I like to separate the connection from the command from the reader. And there's a reason for this, because you don't always want to execute reader. Sometimes you want to do an insert, or sometimes you want to do some other database function that's not covered by execute reader. So let's go ahead and do a little bit more abstraction, because I think we can make this just a bit better. Now we can say and we can put this fun stuff here into this Lambda body right there. Now, so far this hasn't bought us just a whole lot, but I'll show you as we get deeper into the tutorial why this is a good thing. So now let's do the same thing. Okay. Now we've got our command. And so let's go ahead and implement this here. Now we've got this basic pattern set up here. And let's go ahead and apply it to our system here. Okay. There we go. And one last time here. Okay. Now we've made things just a little bit cleaner. Now, why does this matter? That's the question that everyone's asking ourselves, because we still have these three methods. We're still doing basically the same thing. So why does this matter? So now, flash forward a month, 2 months, a year, and something bad happens, our database goes down, somebody changes a table, somebody does something, and we realize that the lack of error control is hurting our application. So now, instead of 3 places, we can come in and do it in 1. Now, that's pretty good, except whatever we specify to do here on line 51 is going to be the global execution handling for everything to the end of time, whatever. And that's no good. We don't want to do that. So first, let's define a default methodology of handling the error. So we might want to say and typically I like to log exceptions because it's always a good thing to do. Oops. And I forgot my $sign. If this pattern right here is new to anyone, this is part of the new C# language definition. I think it came in 6, maybe 7. If you're seeing this for the first time, I urge you, and I'll put a link in the description below, to check out some of the new language patterns and new functions that they've added to C#, because the Microsoft guys are constantly hard at work adding new features and new facilities for developers to make lives easier. And it's just a good thing. Like I said, I'll include that in the comment section below. But continuing forward. Now, I always like to log the exception class name, because oftentimes you won't get a message. So for like null pointer, I think null pointer is one of them, but I don't remember off the top of my head. But there are cases where you'll get an exception but no message. So I like to put the exception name in just to be cool. And oh, another thing I'm doing here, in case any of you are wondering, and some of you may notice this is familiar, I am using nlog for my logging. Again, it's my default go-to. You can set it up to do web service calls. You can set it up to do database. You can do all kinds of exciting stuff with nlog. And it's nice. It's lightweight. You can apply it to anything. Again, it's like I said, it's my go-to. So that commercial for nlog done. So that's nlog, and the JetBrains people got free commercials on this video. So there you go. So now let's wire up our handle exception. So what are we going to do? The easiest thing to do is to bring in our good old friendly action. And we're going to default this parameter to null, because we know this application is going to handle this in the default manner. And so there's no need to do anything unless we want to do something other than what it does by default already. So we come in here, do a quick no coalesce. And if except is null, then we want to use handle exception. Good. Now, we're going to come in here and accept, or accept. Now, writer's giving me a warning with a possible null reference exception. And this is a very important warning because there's one very important thing I forgot to do, which is protect our lambdas, protect our delegates against nulls. So if somebody for some reason calls us with a null value, we just won't do anything. Okay, and now we're safe. Let's go ahead and propagate our accept down through our methods so that we can add exception handling at any layer we want to. Now we have exception handling, and we were able to do that with very limited code across all three things, giving us hooks for exception handling at each stage along the way. So let's return back to our enumerable dictionary. One of the things that I don't like is that we're doing field naming by hand. I'm lazy, and I think it's good for developers to be just a little bit lazy, but lazy in the right direction. Not in terms of keystrokes or that kind of thing, but in terms of I don't want to have to repeat myself. I'm a very big believer in dry. So if we look here, we're pretty good, but we've still got a lot of repetition going on here, right? So we can see the same pattern of code happening all over the place. So the next change that I'm going to suggest all right. Now we can simplify even more. Now let's go ahead. I don't like using stars. I should have fixed that earlier, but and finish this up, and there we go. Now we can add additional data methods and keep it very clean. We could just even use the get data in our main application here. But now I wouldn't say simplified, we've abstracted the different concepts out. Now we can build database actions at will at any level from connection to command to query. Again, this is not the ideal way to structure things, and there's a lot of Entity Framework folks who I'm sure will go into at length the problems of wrapping database queries. And we haven't discussed parameterized queries. We haven't discussed keeping things safe from SQL injection. Again, this is just a simple tutorial, and I'm just taking a basic interaction that a lot of people use. So that does it for now. So that's basically the concept, is this kind of pattern here, where we're using lambdas to act on noisy I/O operations that require a lot of exception handling, that require maybe a dispose pattern, and so on and so forth. But as you can see down here in our code, we're not dealing with any of that. And for each new database action that we want to do, say we want to use data tables instead of list dictionaries, whatever you want to do, right? So thanks for watching. That's all I have for this week. Next week we'll be back with another tutorial. Let me know in the comments if you found this helpful, or let me know if there's a topic you'd like to see covered, and we'll take a swing at it. But for now, I'm Will, and this is Tech Talk, and again, thank you for watching.